everyone, welcome to Robert Morris University Math 0900. This is Brianne Pernick and we are going to begin working on Chapter 7, Lesson 1. In this lesson, we are going to work on plotting a point given the coordinates, determining the coordinates of a plotted point, and finding ordered pairs for a given linear equation. There are several important vocabulary words that you need to make sure that you understand the meaning of before the end of the lesson. The first topic that we are going to start with is plotting a point given the coordinates. The graphing system that we use is called the rectangular coordinate system. It is the system that is formed by intersecting a vertical and horizontal number line, which we refer to as the X and Y axes. The horizontal number line is called the X axis, and the vertical number line is called the Y axis. The point where the two axes intersect is referred to as the origin. So the graphic that's shown here shows all three of those important vocabulary words that I just referred to. So we can see the X axis, which is our horizontal number line, the Y axis, which is our vertical number line, and then we can see the intersection of those, which is referred to as the origin. We represent points in this rectangular coordinate system by using what is called an ordered pair of numbers. The numbers in an ordered pair are referred to as the coordinates of the point. So an ordered pair is always written in a set of parentheses, just as shown here in our examples. For example, we have ordered pair 5, 2, in ordered pair X, Y. The first number, which is the number on the left of the ordered pair, is referred to as the X coordinate. It represents the location of the number along the X axis. The second number, which is the number on the right side of the ordered pair, is referred to as the Y coordinate, and it represents the number's location along the Y axis on that coordinate grid that I showed you before. So the first example that we're going to look at here is one in which we plot the ordered pair 5, 2 on the rectangular coordinate system. Once we plot it, we want to label it as point A. As I mentioned, since the first coordinate represents the X value, you always want to make sure that you are moving along the X axis according to the location as represented by that X coordinate. So since our X coordinate is positive 5, we're going to move over to where positive 5 is located on the X axis. The Y coordinate is 2, a positive 2. So we're now going to move up 2 units and put our point, and we will label that with a capital letter A. And that is how we plot an ordered pair. I would now like for you to plot ordered pair 3, 4 on the same grid, and please label this as point B. Go ahead and pause the recording, label your point, and as soon as you're ready, go ahead and press play and we will check your work. Okay, at this point you should be ready to check your work for how you plotted point B. Since the X coordinate is 3, you should have moved over 3 units to the right, and the Y coordinate is 4, so you should have moved up 4 units. and put your point right there, and we would label that with a capital letter B. So example 2 is some more practice using the rectangular coordinate system. So we have 3 more examples here where you can label points F, G, and H respectively. So please remember that if it's a negative, you should be either moving to the left on the x-axis or downward on the y-axis, depending on if it's an x-coordinate or a y-coordinate. Please go ahead and take a moment and graph points F, G, and H. As soon as you're ready, please press play and we will check your work together. Okay, for point F, you should have moved to the left 5 units and down 3 units. And that's point F. Point G, we should have moved to the right 2 units and down 6. There's point G. And point H, we should have moved to the left 6 and up 2. And there is point H. So hopefully you did okay with the graphing of those 3 points. Example 3 has us graphing a few more points there. So I will allow you to have a moment here to graph these ones. Just a hint that when you have an improper fraction, it is easiest to graph that when you convert it to a mixed number. Go ahead and pause the recording, graph those points, and as soon as you're ready, press play, and we will check your work together. Okay, by now you should have had an opportunity to graph points F through L, and you should be ready to check your work with me. For point F, our x-coordinate is 0, so we should not have moved anywhere. We're going to actually stay on the y-axis. The y value is 5, so we're going to move up 5 units and label that as F. For point G, our y-coordinate is 3, or excuse me, our x-coordinate is 3, so we're going to move over to the 3. Our y-coordinate is 3/2, so it's best to think of that as 1.5. So I'm going to put my point at 1.5 and label that as G. For letter H, we have negative 6/4, so we're going to move to the left 6 and up 4 and label that as H. For I, we're moving to the left 3 and down 4 and labeling that as I. For J, we're moving to the left 4 and we are not moving up or down. We're keeping that right on the x-axis. It has no height to it. Letter K, we're moving to the right 2 and down 3. Sorry about that. So we wanted to move to the left 3, or to the right 2 and down 3, I apologize, and label that with a K. And lastly, for letter L, point L, we're moving to the right 6.5 and down 7.2, so approximately right there, and we label that as L. So hopefully you are okay with plotting points. If you need any help with that concept, please feel free to get in touch with me. Our next topic is determining the coordinates of a plotted point. Sometimes it is necessary to find the coordinates of a point that has already been plotted. So we're simply going to reverse the steps that we just took. First, we will count the units that we have moved on the x-axis to get as close as possible to that point. Next, we count count up or down the number of units that we've moved along the y-axis. And that's going to give us the x and y coordinates for our ordered pair. So let's take a look at example 4. It says, what ordered pairs of numbers represent point A and point B on the graph? Well, for point A, we're going to start with our x coordinate. So we're going to see how many we moved over to the right. We moved 1, 2, 3, 4, 5. So that tells me that my x coordinate was 5. And then I moved up 1, 2, 3, 4. So my y coordinate was 4. So my ordered pair was 5, 4. That was 4A. And for ordered pair B, we moved 1, 2, 3, 4, 5 to the left. So my x coordinate is negative 5. And then we moved 1, 2, 3 down. So my y coordinate is negative 3. So that gives us ordered pair negative 5, negative 3. I would like for you to go ahead and complete student practice 4. Please go ahead and find the ordered pair that represents point C. Go ahead and pause the recording and press play as soon as you're ready to check your answer. Okay, at this point you should be ready to check your answer for ordered pair C. You should have seen that on our graph we did move over 1, 2 units, so our x coordinate is 2, and then we moved up 1, 2, 3, 4, 5, 6, 7. So there you have that our y coordinate is positive 7. So point C has ordered pair 2, 7. Now sometimes we will be examining data from real-world solutions, and we often find that plotting data points shows useful trends. In such cases, it's often necessary to use a different scale, one that displays only the positive values. If you think about that, sure, the number line could be displayed, but in such cases as years, is it necessary to show negative years or negative production of cars or negative automobile accidents? That doesn't really make much sense in real life, so it's not necessary to show it. So in example 5 here, we are looking at the number of motor vehicle accidents in millions, and this is recorded in the following table from 1980 to 2005. What we want to do is, for letter A, it says plot points that represent this data on the given coordinate system. And then for letter B, what trends are apparent from the plotted data? Well, for letter A, this is done for us. We can see that the ordered pairs of 0, 18 has already been graphed. Ordered pair 5, 19 was already graphed. Ordered pair 10, 12 was already graphed. Each one of these was already graphed here. So as you're analyzing this graph for part B, what trends are apparent when you're looking at the number of motor vehicle accidents over the years. Take a second and think about that. Now, obviously, Part B has been answered for us. It says from 1980 to 1985, there was a slight increase in the number of accidents. From 1985 to 1995, there was a significant decrease in the number of accidents, although from 1995 to 2000, there was a moderate increase in the number of accidents, and then again, it decreased in 2005. So once you get that data, those ordered pairs graphed, you can then analyze them and make them into data that makes sense and is useful to you in real life. And sometimes that isn't exactly easy to see until you get it graphed on a graph. So just looking at a table of ordered pairs may not necessarily be the easiest of things to understand. Okay, student practice 5. We are essentially doing the same thing here, only this time I would like for you to go ahead and do it. Go ahead and graph the ordered pairs and then come up with the trends that are apparent to you from your plotted data. Please go ahead and pause the recording, and as soon as you're ready, press play and we will talk about the graph and what this should look like. Okay, by now you should be ready to go over the graph and the results. So we should have graphed 0, 51, 5, 44, 10, 45, 15, 42, 20, 42, and 25, 44. So as we look at this data, we can see that in the year 1980, there was an extremely large number of motor vehicle deaths. So I would say that the trend at that point in time was that there was an extremely large number of reported deaths at that time. However, around 1985, remember our increments are in years since 1980, so we're going every 5 years, so that would be about 1985 and following. The number of deaths have dropped and apparently leveled off. So as you can see, looking at that, they have dropped and become relatively stable. They might have gone slightly up or slightly down, but they definitely dropped and seem to have stabilized. Our next topic that we're going to cover here, and this is the last topic for this section, is finding ordered pairs for a given linear equation. Equations such as 3x plus 2y equals 5 and 6x plus y equals 3 are called linear equations in two variables. They are called this because, surprise, they contain two variables in them. There's no other reason for it. It's not a tricky reason. It's literally because they contain two variables. So a linear equation in two variables is an equation that can be written in the form ax plus by equals c, where A, B, and C are real numbers, but A and B are not both 0 at the same time. Replacement values for A and X that make true mathematical statements of the equation are called truth values. And an ordered pair of these values is called a solution. So when you plug in X and Y values and you end up with a result that is true, and that result makes an ordered pair, that ordered pair is a solution to your equation. That's what that paragraph is saying there. So an example of what that whole thing was talking about is that if we take the ordered pair 1, 1 and plug it into the equation 3x plus 2y equals 5. 3 times 1 is 3. 2 times 1 is 2. And 3 plus 2 is 5. So 5 equals 5. That means that 1, 1 is a solution to that equation because it resulted in a true mathematical equation. However, if you were to plug that in and you did not obtain a true value, then it would not be a solution. So what we're going to look at in example 6 is whether or not the ordered pairs are solutions. And the way that we do that is simply by plugging the x coordinate in for x, we plug the y coordinate in for y, we simplify using the order of operations, and we test for truth. So we're going to plug into the equation that we were given. We were given the equation 3x plus 2y equals 5. We're going to substitute. We have 3 times negative 1 plus 2 times 4 equals 5. And now we want to just start doing the math and testing for truth. 3 times negative 1 is negative 3. 2 times 4 is 8. Bring down the equals 5. Negative 3 plus 8 is 5. Does 5 equal 5? Sure does. So that means that negative 1 comma 4 is a solution to that equation. Now let's check ordered pair 2, 2. We're going to do exactly the same thing. We're going to plug in 2 for x. Let me get my eraser there since I wrote a 2 instead of a 3. So we're going to plug in that 2 for x. So we have 3 times 2 plus 2 times 2 equals 5. And we're going to test for truth. So 3 times 2 is 6. 2 times 2 is 4. And bring down the equals 5. We have 6 plus 4 is 10. And now we have 10 equals 5. That is not true. So that means that this is not a solution, since that was not a true mathematical sentence. So at this point, you guys can go ahead and try student practice 6. Go ahead and pause the recording, and as soon as you're ready, press play, and we'll check your answers together. Okay, at this point you should be ready to check your answers to student practice 6. We're going to take the equation 3x plus 2y equals 5 and plug in ordered pair 3, negative 1. So we have 3 times 3 plus 2 times negative 1 equals 5, and we're going to test for truth. So 3 times 3 is 9. 2 times negative 1 is negative 2. 9 minus 2 is 7. 7 does not equal 5. So our first ordered pair was not a solution. For part B, we are working with the same equation, 3x plus 2y equals 5. So we're going to plug in, we did it again, 3 times 2 plus 2 times negative 1/2 equals 5. 3 times 2 makes 6. 2 times negative 1/2 makes negative 1. 6 minus 1 is 5. So 5 equals 5. That is a true mathematical sentence. So we can say that yes, that is a solution. Our last example type for today deals with if we know one value of an ordered pair solution to a linear equation, the other one can be quickly obtained. To do so, we would replace the proper variable in the equation by the known value, and then we would simply solve for the other variable. So let me show you what I'm talking about. We're going to start with our equation. We have 2x plus 3y equals 15. They gave us 0, question mark. That means that we were given the x value, but we do not know the y value. So we're going to replace the x value with 0, and now we're going to solve for y so that we can figure out the y value from our ordered pair. So 2 times 0 is 0, plus 3y equals 15. That simplifies to 3y equals 15. Divide both sides by 3, and we can see that the y value for that ordered pair was 5. So that means that the original ordered pair should have been 0, 5. Example B, very similar. We have 2x plus 3y equals 15. This time we were not given the x coordinate, but we were given the y coordinate. So I have 2x plus 3 times 1 equals 15. So we're just going to simplify down. 2x plus 3 equals 15. Subtract 3 from both sides. 2x equals 12. Divide both sides by 2. And the x coordinate is 6. So our original ordered pair was 6, 1. You can go ahead and do student practice 7. As soon as you are ready, please press play and we will check your work. Okay, at this point in time you should have had an opportunity to complete examples A, B, and C. So what you should have done here is started with your original equation, 3x minus 4y equals 12. For example A, you were given your x coordinate, so we should have plugged in 0 for x and then worked our way down to solve for y. 3 times 0 is 0. That term disappears. Negative 4y equals 12, not negative 12, 12. So negative 4y equals 12. Divide both sides by negative 4. Y equals negative 3. That means that our original ordered pair was 0, negative 3. For example B, we're going to start the same way with our equation. This time we were given the y coordinate. So we will plug in 3 for y and solve for x. We have 3x minus 12 equals 12. We need to add 12 to both sides. 3x equals 24. Divide both sides by 3. and x equals 8. That tells us that our original ordered pair was 8, 3. And lastly, we have example C. Again, starting with the equation, we were again given the y coordinate, so we need to plug -6 in for y. So we have 3x plus 24 equals 12. Please remember that a negative times a negative makes a positive. We will need to subtract 24 from both sides. So 3x is going to equal -12. Divide both sides by 3, and x equals -4. So your ordered pair is -4, -6. This concludes our lesson for section 7.1. If you have any questions about this content, please feel free to contact me. We can set up a time for tutoring if need be, or just simply answer your questions. Thank you and have a great day.